Okay, finishing up the review assignment, we're going to try to get 9 and 10 both in this video. So in number 9, you're given an expression for the height of an object thrown vertically, and you've got 9.8 as your g. So if we plug all of our values in, we have h of t is equal to negative 1/2 times 9.8 t squared plus 20t plus 150. Okay, and the first thing we're doing is being asked to find the time at which the object reaches its maximum height. Again, maxes and mins, I'm thinking take the derivative, set it equal to 0. So for part A, we take the derivative h prime of t, which, by the way, also represents the velocity. And the negative, we take the derivative. So 2 times 1/2 goes away, and I get 9.8t. If you'd rather simplify that to, I believe it's 4.9, you can do that. Plus 20. And we're going to set it equal to 0. And solve. So 9.8t is equal to 20, and t is equal to 20 over 9.8, which turns out to be approximately 2.04 seconds. Okay, that's part A. Find the maximum height. If that's the time it takes to get to the maximum height, then to get the maximum height, I'm going to plug in 2.04 into my equation for height. So negative 1/2 of 9.8 times 2.04 squared plus 20 times 2.04 plus 150. If I do that, I've got 170.4, and that is in meters. Okay, because our velocity is given in meters per second. All right, C. Find the velocity of the object at the time it reaches its maximum height. Okay, so there are two ways to do this. Number one is to say, okay, I know that it takes 2.04 seconds to get to its maximum height. My equation for velocity is the derivative, right? The derivative of position is velocity. So if I plug my 2.04 in there, that'll give me the velocity, right? However, I found the 2.04 by setting the velocity equal to 0. So if I plug 2.04 back in, I should get the velocity. V at 2.04 should be equal to 0. Okay. The other thing is that find the at the maximum height, the velocity should be 0 because the object is turning around. So it has a positive, depending on how you set it up, it has a positive velocity going up, stops, and turns to come back down. So then it has a negative velocity, or vice versa, depending on how you set it up. But either way, at the very top of the height, where it changes direction, your velocity should be 0. And letter D, at what time does the object reach the initial height again? Well, the initial height, they tell us, is 150 meters. So if I set this up for my height and set that equal to 150, I can then subtract 150 from both sides and get 0 equals negative 9.8 t squared. Half of that, right? Plus 20t. Then we get 9.8 over 2t. Sorry, hold on. What I want to do is I want to factor out a t. And 9.8 over 2 is 4.9. So that's negative 4.9t plus 20. This will give me t equals 0. Rightly so, because that was the initial height. And then this one will give me the answer to what they're asking. So if I set negative 4.9t plus 20 equal to 0, that means I get 20 over 4.9. So 4.08 seconds. And it's not a coincidence that that is double the time to the maximum height. Okay. So that is number 9, and that's kind of our application to physics. And then lastly, number 10 is our antiderivative, so I want to capture these quickly. So for letter A, you have f of x, 32x cubed, minus 9x squared, plus 6x, minus 4, and I'm going to write it right away as x to the minus 2, plus 9x to the 1/2. right? And I'm being asked for capital f of x, which is the antiderivative. So I'm taking 32, I increase the power to 4 and divide by my new exponent. Minus 9, increase my new exponent to 3 and divide by it. 6, increase my exponent to 2 and divide by it. Minus 4, increase my exponent by 1 and divide by it. 9, increase my exponent to 3 halves. And instead of dividing by 3 halves, I'm going to multiply by the reciprocal. So times 2 over 3. Plus a constant. Don't forget your constants. So this gives you 8x to the 4th minus 3x cubed plus 3x squared minus, actually plus because these two cancel out, 4 over x. This becomes 6x plus 6x to the 3 halves plus a constant. For B, we want to simplify this. And so I'm going to split this 20x over 2x and 12 over 2x and simplify. So that's going to give me 10 minus 6 over x. And I'm going to pull that 6 away from the x. So it's 6 times 1 over x. So that when I go and find my antiderivative, that's going to be 10x minus 6. And 1 over x is the special case that becomes the natural log of the absolute value of x. And then lastly, for C, here's your trig functions. Hi there. I've got the secant x tangent x plus the sine of x. And find our antiderivative there. We'd find the antiderivative of secant tangent, which is secant x, and the antiderivative of sine, which is negative cosine x, and add on our plus c.